Today we're looking at the chain rule. That's where we're differentiating a composite function. The example you see here, we're going to take the x, multiply by 2 and add 3, and that answer will then be squared. It's a composite function because more than one thing is happening. When we undo functions like this, we work backwards. So if I wanted to undo this function, I would square root first, then I'd subtract 3, and then I'd divide by 2. When we're differentiating, we work in the same order. I'm going to deal with the outside function first. So when I'm differentiating, I use the same rules as I've always done. So I'm going to multiply by this power, and then I'm going to reduce the power by 1. When I'm doing that, I'm going to be leaving this bracket right alone, not making any changes to it. So multiply by the power, keep the bracket as it is, reduce the power by 1. Now I can start to look at the inside function. And at this point, I'll differentiate what's inside the brackets. So 2x plus 3 would differentiate to be 2. So I'll multiply by that derivative. I can tidy that up, and it will be 4 times 2x plus 3, which is fine in factorised form, or I could also say 8x plus 12. When you first look at a function, you won't always see the brackets there, sometimes we'll have to put them in. We're going to look at a couple of examples from your notes. In this example, on page 21, I've got a function which is 2x squared plus 3x, all square rooted. It's a composite function. The 2x squared plus 3x happens first, and then that answer will be square rooted. So I'm just going to rewrite this with brackets. So 2x squared plus 3x, and then it's square rooted, so that's to the power of a half. So when I differentiate, I'm going to deal with the outside first. So I'm going to multiply by the power, leaving the bracket alone, and I'm going to reduce the power by 1. Now at this point I'm going to look at the inside of the bracket, and I'm going to multiply by the derivative of that. So I've got 2x squared, which will differentiate to 4x, plus 3x, which differentiates to 3. And I'm now going to combine this together. So I've got a half of 4x plus 3 multiplied by 2x squared plus 3x to the power of negative a half. I'm going to tidy up, I don't want that negative a half, fractional negative indices. The negative will tell me it's all going underneath, so it'll be beside the 2. The half tells me that it's a square root. This has a positive power of 1, so it's going to stay on the top. So I will have 4x plus 3 over 2 times the square root of 2x squared plus 3x. We are skipping example 2 for the moment, we'll come back to that. Example 3 on page 21 is y equals 5x plus 2 all cubed. So I'm going to differentiate the outside first, so multiply by the power, keep the bracket the same, reduce the power by 1, then multiply by the derivative of what's inside the bracket, 5x plus 2, and if I differentiate that, I get 5. To simplify it, I've got 3 times and 5 times, so I've got 15 times 5x plus 2 all squared. Okay, we're going to flip now to page 22. Here we have a function y is 1 over 2x plus 6 cubed. Now in the same way that we didn't like to have x underneath a bracket when we were differentiating single functions, we don't like x under the bracket with composite functions either. And we can use the same index rules. We can bring this whole bracket up just by changing the power by multiplying it by -1. So now I'm in a situation where I can differentiate the outside first by multiplying by the power and reducing the power by 1, keeping the bracket the same, then multiplying by the derivative of what's inside the bracket. Tidy those together, so -3 times 2 is -6. And I know that I've got an index of -4 here, so to get rid of the negative I'm going to want to put that under the fraction. So -3 times 2 is -6, and it's over 2x plus 6 to the power of 4. And our last example, 5, which is also on page 22, we have 3x minus 2 to the power of 4, all cube rooted. I'm going to get rid of that cube root and make it a fractional index. So it'll be 3x minus 2 to the power of 4 over 3. Remember, the denominator is the order of the root and the numerator is the order of the power. Now I'm in a position where I can differentiate starting from the outside. So multiply by the power and reduce the power by 1. So 4/3 take away 3/3 is 1/3. Now I'm going to multiply by the derivative of the inside. So 3x minus 2, if I differentiate that, I'll get 3. I'm going to tidy up. 4/3 multiplied by 3 is just 4. The 3x minus 2 is to the power of 1/3, so that means that it's a cube root. Not underneath the fraction because it's not negative. Okay, just want to check you've got the main points from today. So do you differentiate the inside or outside function first? Remember, the chain rule is something we use for composite functions. So inside or outside function first. And then can you differentiate these two examples below? And we're now in a position to complete question 1 from each of these exercises, 14E, G and H. E is unit level, G is level C, and H is level AB.